We're doing a deep dive based on Google's latest announcement. It's about their 7th generation Tensor Processing Unit.
Their custom AI chip, yeah.
Called Ironwood. Sounds pretty solid.
It does. And Google designs these TPUs, these Tensor Processing Units, specifically to accelerate AI tasks. Ironwood looks like a really significant step up. Inference being the key word there. That's when the AI is actually, doing things, giving answers, generating insights, being responsive.
Okay, Ironwood. 7th generation TPU. What makes this chip, this piece of silicon, stand out?
Well, the first really critical point is that focus you just mentioned. Inference. We hear tons about AI training, right? That huge upfront effort to teach the model.
Yeah, the learning phase.
Inference is what comes next. It's the trained model actually applying what it learned, making predictions, writing text, answering your questions in real time. It's the AI being, you could say, proactive, providing value.
Right, so Ironwood isn't primarily for the learning, it's for the doing. And specifically for these really demanding thinking models, the ones making waves, the LLMs and MOEs.
Precisely. That's its sweet spot. Google is stating right out of the gate that Ironwood is their most powerful, most capable, and most energy-efficient TPU they've ever built.
Powerful, capable, efficient. Got it.
It's really engineered to handle the immense computational load and the sheer amount of communication needed when these cutting-edge AI models operate at, massive scale.
Scale seems to be the operative word here. You're talking potentially thousands of these chips all networked together.
We are. And the numbers, honestly, are pretty staggering. A single Ironwood pod, that's their term for these clusters, can integrate up to 9,216 of these chips.
Wow. 9,216 chips. And they're liquid-cooled, you mentioned.
Yes, liquid cooling is essential at this density and power. And the total compute power from one of those fully kitted out pods, it hits 42.5 exaflops.
42.5 exaflops. Okay, that number is almost abstract. How can we even, put that into perspective?
It's tough, isn't it? But Google gives a comparison themselves. They point out that one Ironwood pod has over 24 times the compute power of El Capitan.
El Capitan, the current biggest supercomputer.
That's the one, which apparently clocks in around 1.7 exaflops per pod. So you see the jump, it's enormous.
24 times. Okay, that helps frame it. And a single chip.
Even one Ironwood chip is a beast. It peaks at 4,614 TFLOPs, teraflops.
So having this many chips working together, this massive parallelism, that's what lets these incredibly complex AI models actually think or process fast enough to be useful.
That's exactly it. These models are running unbelievably intricate calculations on just vast seas of data. Ironwood's design is fundamentally about tackling that massive parallel workload efficiently.
Minimizing the choke points, maximizing the crunching speed.
You got it. Keeping everything flowing.
Okay, beyond the sheer number of chips and that headline exaflops figure, what are the key technological advancements inside Ironwood? What makes it tick faster or smarter?
Good question. There's several important upgrades. Let's start with something called the Enhanced Sparse Core.
Sparse core. Okay.
Think of it like a specialized accelerator. It's designed to handle these ultra-large embeddings really efficiently.
Embeddings, those are like how the AI represents relationships between concepts, words, images, that kind of thing.
Exactly. They're fundamental for understanding context. Super important for things like search ranking or recommendation engines. But what's interesting with Ironwood's enhanced version is that its capabilities stretch beyond those typical AI jobs. Google mentions it extending into financial modeling, even scientific discovery domains.
So not just recommending movies, but maybe spotting subtle trends in financial markets.
Right.
Or speeding up research for, say, new medicines.
Precisely. The improved sparse core opens doors for tackling these very complex, data-heavy problems in a wider range of fields. That's a significant expansion.
Okay, what else?
Another major upgrade is high bandwidth memory, or HBM.
Right, memory on the chip itself.
Yeah. Each Ironwood chip packs 192 gigabytes of HBM.
192 gigs. How does that compare?
That's 6 times the HBM capacity of the previous generation, which was called Trillium.
6 times? Wow. What does that mean in practical terms? What's the benefit?
It means you can fit much larger, more complex AI models and the data they need to work with directly onto the chip.
Ah, so less shuffling data back and forth to slower memory somewhere else.
Exactly. That shuffling takes time and energy. Keeping it local dramatically cuts down latency and boosts performance.
Makes sense. Faster processing.
And it's not just the amount of memory, it's also the speed it can be accessed. The HBM bandwidth.
Okay.
Ironwood delivers 7.37 terabytes per second of bandwidth per chip.
7.37 Terabytes per second.
per chip. Yeah, that's 4.5 times the bandwidth of Trillium.
That sounds like an incredible fire hose of data. Why is that speed up so important?
Because these models are incredibly memory hungry. They need constant, rapid access to data to keep the processing units fed.
Right. Can't have the engines idling while waiting for fuel.
Precisely. This high bandwidth ensures the computational cores aren't starved, maximizing the efficiency of those complex calculations we talked about.
Got it. So better sparse core, way more memory, way faster memory access. Anything else key?
One more critical piece is the interconnect between the chips, the ICI, or inter-chip interconnect.
The communication network linking all those thousands of chips.
That's the one. Its bandwidth has also increased significantly. It's now 1.2 terabytes per second bidirectional,
Which is.
1.5 times faster than Trillium's ICI.
And why is that faster chip-to-chip chat so vital?
Because when you're coordinating tasks across potentially over 9,000 chips, that communication has to be lightning fast and efficient. It's what allows them all to act as one single massive coherent computing system for these distributed AI tasks, training or inference.
Okay, that paints a picture of serious power. But, with great power comes a great electricity bill, usually. AI's energy use is a growing concern. How does Ironwood stack up there?
That's a crucial aspect, and Google seems very focused on it. They're claiming a really significant improvement in power efficiency.
How significant?
Ironwood apparently delivers twice the performance per watt compared to Trillium.
Double the performance for the same energy cost.
It's essentially, yes.
Yeah.
Or the same performance for half the energy. In a world where power availability is increasingly becoming a bottleneck for scaling up AI.
Right. We hear about data centers struggling for power.
Exactly. So doubling efficiency like this is a major, major win. It makes scaling more feasible.
How did they achieve that? Is it just the chip design?
It's a combination. Advanced liquid cooling helps manage heat, allowing things to run efficiently, plus optimizations in the chip architecture itself. And just to give some historical context, Google says Ironwood is nearly 30 times more power efficient than their very first cloud TPU, which came out back in 2018.
30 times better than 2018. That really shows the pace of improvement. Incredible.
It really does. It's a relentless march towards more compute per watt.
So pulling it all together, this massive power, the focus on inference, the efficiency gains.
Yeah.
What's the overarching narrative here? What does Ironwood enable for the future of AI?
Fundamentally, Google positions Ironwood as the hardware powering what they call the age of inference.
The age of inference.
It signifies a shift. Moving beyond AI that just passively responds to prompts towards AI that can, proactively generate insights, maybe anticipate user needs, offer solutions more dynamically.
So less like a search engine waiting for a query, more like a collaborative partner.
That's a good way to think about it. Imagine more sophisticated AI assistants that can actively pull together information, analyze it, synthesize it, maybe even help you brainstorm complex problems in real time.
Okay, I can see the potential there. And Ironwood is sort of the engine for that within Google Cloud's ecosystem.
It's a core component, yes. Part of their broader AI hypercomputer architecture. The idea is to tightly integrate the hardware, like Ironwood, with the software needed to manage these huge workloads effectively.
Software-like.
They mentioned their Pathways software stack, which comes from Google DeepMind. It's designed specifically for orchestrating these massively distributed computations across potentially tens of thousands of these Ironwood chips.
And are we already seeing models that need this kind of horsepower?
Oh, definitely. Google explicitly calls out models like Gemini 2.5, their latest large language model, and AlphaFold.
AlphaFold, the protein folding predictor. That was huge.
Revolutionary, yeah.
Yeah.
And incredibly computationally intensive. Those are prime examples of the kind of thinking models already running on their TPU infrastructure. Ironwood just ups the ante considerably.
So the potential for even bigger breakthroughs for Google's own teams and their cloud customers seems pretty immense.
It really does. They seem quite excited about what developers will be able to build with this next generation of hardware.
When can people actually get their hands on this? When will Ironwood be available?
The timeline mentioned in the announcement is later in 2025 for Google Cloud customers.
Okay, so coming next year.
Yeah, and they'll offer it in, it seems, 2 main configurations. There's a 256 chip setup.
For slightly smaller but still large jobs.
Presumably, yes. For organizations with significant AI needs, but maybe not quite at the absolute bleeding edge. And then there's the full Monty, the 9,216 chip pod, for those really pushing the boundaries of what's possible with AI today.
Tailored options. Makes sense. Okay, so let's quickly recap. Ironwood, Google's 7th gen TPU, laser focused on AI inference, especially for these complex thinking models.
Right.
It offers just massive scale, up to over 9,000 chips per pod, delivering incredible compute power, like 42.5 exaflops.
Jaw-dropping numbers, yeah.
Key tech leaps include that enhanced sparse core for complex relationships, huge increases in on-chip memory capacity and speed, much faster chip-to-chip communication.
All crucial for performance at scale.
And importantly, a big jump in energy efficiency, twice the performance per watt compared to the last gen.
Which is vital for sustainability and future growth.
Yeah.
It really feels like a comprehensive step forward.
It definitely sounds like a potential game changer for enabling this next wave of more proactive, insightful AI.
That seems to be exactly the goal, powering that age of inference.
It certainly leaves you wondering, I mean, if this is the kind of leap we're seeing now, with Ironwood representing this exponential curve in power and efficiency, what kinds of AI applications, things we maybe can't even properly imagine yet, might become feasible really soon? And maybe more profoundly, what are the wider impacts on society as AI shifts from being mostly reactive to being much more proactive, more like a thinking partner?
That's the big question, isn't it? Definitely something to mull over.
Absolutely. Well, if you listening want to get into the real nitty-gritty, the technical specs, and learn more about when Ironwood might be available, Google Cloud's website is the place to go for all those details.